Hi, everyone. Thanks for taking the time to be here today. I always love talking to students. We have some great content planned for the presentation today, but let me quickly introduce myself and we'll go from there. I'm Apoorva. I'm a senior data scientist on the security machine learning team here at Elastic, and I lead the delivery of user and entity behavior analytics solutions to Elastic security product. And for today's talk, I'll be focusing on the different capabilities in the Elastic stack that can help you get the most out of your data. But before that, I have, in true lecture style, I guess, I have some questions for you all. So give me a +1 in the chat if you know what Elasticsearch is. All right. And give me a +1 if any of these sound familiar to you at all, like ingest pipelines, aggregations, transforms. These are capabilities that I'll be talking about more today, but just wanted to get a sense of whether or not people have heard about these before. Awesome. All right, so let's get started. So today I'll start with a quick recap of what a machine learning lifecycle looks like in a production setup. I'll then talk about how the Elastic Stack can help, especially when it comes to data analysis, visualization, data cleaning, and enrichment with some demos and examples of how you can do this in the Elastic Stack. I'll also talk about some security machine learning case studies where we've actually used some of these techniques for models that my team ships today. And we'll also have a lot of time for questions towards the end, but if you have questions during the presentation, feel free to interrupt me. So let's take a quick look at what a machine learning lifecycle looks like in a production setup. There's 3 main stages when it comes to this, namely planning, data engineering, and modeling. And for today, I'll be focusing mostly on the data engineering aspect, but I want to spend a couple of minutes just touching up on the other 2 as well. So the first part, which is planning, mainly involves talking to the different stakeholders like product managers to figure out what the machine learning model must do and how it fits into the overall landscape of your product. Then the next step is data engineering. And if you've ever worked on a data science project in school, you know, even at this point, that data cleaning and pre-processing is where you spend the bulk of your time. And as you can imagine, the reason this is because what you do in this phase impacts everything downstream, like how long it takes to build your ML models and how good your models actually are. And data engineering mainly consists of 4 tasks, right? Figuring out what you're going to, where you're going to store your data, being able to extract it easily from your data store, analyzing the data to find interesting trends and patterns in it, and finally processing it in a way that's suitable for training models on top of that. And then once you have your data in a good place, you're then ready to start modeling, which involves thinking about what features you want to extract from your model, for your model, deciding what models you want to use, where and how to serve the final model that you're building. Is it going to run as a plugin? Is it going to run in the cloud? Is it going to run on-prem? Things like that. And then there's finally monitoring your model to check for any performance degradations and to make sure that it's working as expected. And with that, let's get into how the Elastic Stack can help with some of these tasks. So first off, it is the perfect data management tool. And how is that? Because it's a distributed search and analytics engine, it has a way to store and retrieve data efficiently. And it does this by being distributed in nature. And what that means is you can add nodes, which means servers to your Elastic cluster, and it will automatically distribute your data and query load across all available nodes. And this is what makes it a great tool for data storage, management, and extraction. Adding to it the fact that it also has its own query languages called Query DSL and KQL, which can be used to query and visualize data. And it also has several tools for pre-processing your data. And by pre-processing here, I mean things like redacting personal information from data, data normalization, or building aggregate features from your raw data, which are all useful tasks when it comes to building machine learning models. And we look at each of these in a little more detail. But before that, I just wanted to point you all to some resources that you can use to experiment with some of the capabilities that I'll be talking about in today's presentation. So before you can use Elasticsearch, you need something called an Elasticsearch cluster. And it's as easy as starting up a free trial of Elastic Cloud these days. You can literally pick a cloud computing environment of your choice and spin up an Elastic Cloud instance, which comes equipped with everything you need. And then once you have a cluster up and running, there's some sample data sets available by default for you to import and play around with. And in today's presentation, you'll be seeing a lot of examples based on one of these sample data sets, which is the flights data set. And finally, if you're using Elasticsearch tooling as a part of a project written in, say, Python, then there's a Python Elasticsearch client, which has some neat capabilities. First, being that it lets you interact with Elasticsearch from outside of Elasticsearch. Then it has something called helpers, which are basically methods which let you bulk ingest and extract data from Elasticsearch. And finally, the client has async support, which means if you have large amounts of data to work with, then you can process it in parallel. And with that, let's jump into the interesting part, starting with data visualization using Kibana. I have a cluster spun up here, so I'm going to go to that real quick. So what you're looking at right now is my Elastic Cloud cluster. And this is Kibana, which is the UI that lets you interact with your Elasticsearch cluster and the data present in it. So let's look at some of the things that Elastic can do for you in terms of visualizing your data. So I spun up my cloud cluster, I've imported the flights data set, and that also comes with a default dashboard. So this is a good way for me to show you some of the visualizations that you can make in Elastic and Kibana. So as you can see, if you have any time series-based data, then there's specific visualizations that you can use for that. Then if you just want to show raw metrics based on some aspects of your data, then there's these metric-based visualizations. And then there's a lot of simple tabular stuff that you can create. And then if you have any geographical data, there's map layers that you can build on top of, and the usual pie chart, and the most useful visualization of all, which is word clouds. So yeah, that's how you build a dashboard. But basically, the place where all of these visualizations reside is under analytics in Kibana, and there's this visualize library, and you can just say create visualization, and you'll have a bunch of options available to you. If you're a beginner, then I would definitely suggest starting with this category called Lens, which allows you to just drag and drop your data, and it even suggests the best visualization types for your data. So with that, going back to the presentation, I'm going to take a pause here to see if anyone had questions about everything I said so far. All right. Yeah, the visualizations you just saw are backed by queries and aggregations under the hood, which is how Elasticsearch filters and calculates metrics and statistics about your data. And you can also query your data outside of a visualization from something called the DevTools console, which also resides in Kibana. I'll show that towards the end of the presentation. But that comes handy in the exploratory data analysis stage of your product, where you're just like trying to query your data, interrogate your data to find, answer different questions. For example, if I want to get the most common destinations in my flights data set, I can write something called a terms aggregation on the destination country. So as you can see, some of you might be familiar writing SQL, but to query Elasticsearch, it's a NoSQL format, which is kind of convenient because it's simple JSON data, and I personally find it a little more intuitive to work with. So yeah, once I write a terms query in Elasticsearch, what it's going to give you on the right here is the top 3 most common destinations in your data set. And there's a whole bunch of other inbuilt aggregation types available in Elasticsearch, which you can combine with one another to create more sophisticated aggregations. And if there's something that you don't immediately find in the inbuilt visualizations, you can also write scripted aggregations that let you write your own custom logic for aggregating your data. And one of my most favorite data transformation capabilities in the stack is something called transforms. And I like to think of transforms as queries or aggregations that persist. So all the queries and aggregations that we were just looking at, transforms allow you to do these aggregations on information across multiple indices. And the other nice thing about these is that it lets you write these out to an Elasticsearch index. And what this does is it makes your data searchable. So you're able to build on top of the results from these transforms. The other cool thing about transforms is that it lets you run your aggregations on a schedule. So if you have any kind of streaming data, then you can run this transform in it and then store it into an index. So going back to our flights data set, let's assume you're trying to create a model to predict a customer satisfaction score for airlines in your flights data set. And you might be interested in possibly calculating features like total number of flights, percentage of flights delayed for, say, a regression model you're building. And this is where you could use a transform to calculate these features before using them in your model. So actually, let me go back here. So what this transform here is doing is it's telling Elasticsearch, look for data in this index called Kibana sample flights, filter out any flights that were canceled, and then finally write the data out to this destination index. And because I want to calculate a score per airline or carrier, I'm going to pivot my data based on the carrier field. And then I'm writing some aggregations to calculate the features that I need for my regression model. So once you run that transform, what it's going to give you is an index that gives you all the information that you need for each carrier, in this case, in your data set. And now I can use this index as the basis for my regression model. Another data processing and enrichment capability in Elasticsearch that I find super useful is something called ingest processors. And what these allow you to do is modify and process your data before even ingesting it into Elasticsearch. You can also do it after, but in a lot of times, especially in a production environment, you're dealing with like streaming data. So you want to be able to do operations on data in real time before you send data to your data store. So Elasticsearch, again, comes equipped with a whole range of inbuilt ingest processors, which support some common pre-processing techniques that one might want to use on their data, like lowercasing things, substituting patterns, dropping certain characters or fields. And it also has something called enrich processors, which allow you to enrich data from one source using data in another source. And just like with aggregations, if you don't find a processor that fits your data processing needs, you can write custom scripted logic to do any kind of processing that you want. And the way to apply ingest processors on your data is by putting them into something called ingest pipelines. And I like to think of pipelines as a map function in Python, if that's a language you've used before. So what this will do is apply each of the ingest processors in your pipeline to each sample in your data set. And the nice thing about ingest pipelines is that you can not only apply them at ingest time, but you can also use them to update your data in place or even reindex it to another source. And then once you've analyzed and processed your data, Elastic also has a capability called data frame analytics, where you can train classification, regression, and outlier detection models on your data. And without going into too much detail here, since we are focusing more on data processing and enrichment, I just wanted to point out some of the capabilities of data frame analytics that apply to data processing, such as auto-encoding of categorical variables in your data, and it also has some smart automatic kind of feature selection. So this way you don't need to worry about doing these tasks during the pre-processing stage. And I guess the final thing I wanted to highlight is something called inference processors, which is also a type of ingest processor that allows you to enrich your data with predictions coming from a machine learning model. So you can simply include this inference processor in your ingest pipeline, consisting of all your other pre-processing processors. So what this is going to do is whenever you have a new document coming into your into Elastic, it will first get cleaned up using the pre-processing processors, and then it also gets enriched with a prediction about what your model thinks about that particular data point. And the good thing is you don't necessarily have to train these models that you're using for inference in Elasticsearch either, although you can, but you don't have to. You can import models trained externally into Elasticsearch and then use them for inference as well. And again, I know this is a lot, so I wanted to pause to see if there's any questions before I get into some of the real world ML case studies about how we've actually applied these models. All right. Yeah, so I wanted to share some real case studies of models we built on the security team using some of the Elasticsearch capabilities I was just talking about. Starting with Problem Child, which is a machine learning-based framework to identify a certain class of cybersecurity attacks called living off the land attacks. And at a high level, what we did was we used ingest processors and pipelines to pre-process and extract features from our data. And then we trained a classification model also in Elasticsearch using data frame analytics to detect malicious samples in our data set. So the idea here is that if the model flags something as malicious, then that's possibly an indicator of an attack and something we want to flag for further analysis. And one of the biggest problems security analysts face every day is something called alert fatigue, caused by getting too many alerts, or in machine learning terms, too many false positives being generated by noisy rules or machine learning models. So to reduce the false positive problem, we passed the samples flagged as suspicious by this supervised model into Elasticsearch anomaly detection module to only pick out the rarest events for further analysis. And here's some of the pre-built ingest processors and custom script processors that we use for featureization and the data processing field. So as you can see, we used the set processor to set fields to a certain value, something called lowercase and gsub to one convert strings to lowercase. And one thing we end up doing pretty frequently when it comes to data processing is like normalizing the data. So if there's things like hashes, then that's not useful information for a model. So we want to substitute that with using regular expressions or something such to substitute that information with like a placeholder. And then finally, we also wrote some custom scripts to generate n-gram features for the model. And then we also used an inference pipeline to score new events using our supervised models. So as you can see, this is a raw event enriched with the prediction from our supervised model. So this is kind of saying that we predicted that this event is malicious with so-and-so probability. Here's another capability we built using transforms called host risk score, which assigns a risk score and level to hosts in a customer environment based on the kind of alert activity seen on those hosts. And when I say hosts here, I mean employee workstations or internal corporate servers in a customer environment. And the goal here is to help, again, analysts prioritize what to look at when they start their day. And usually you want to start with the most things that are at highest risk and then work your way down that list. So to do this, we used a transform consisting of aggregations containing custom scripted statistical logic to calculate risk scores for hosts, and then an ingest pipeline to assign a risk level based on the risk score that we calculated in the transform. And this is a sample document produced by the host risk score transform. So as you can see, it has a risk, where's the score? Yeah, a risk score for each host. It has a calculated level, using the ingest pipeline, and it also has some metadata about why we flagged this particular host as low risk. And this was all done using a transform. So you can imagine that you can write pretty sophisticated logic in a transform. And because transforms write data out to an index, we are actually able to use the host risk score index to populate several views in Elastic security product. And these enrichments are a crucial starting point for security analysts to start investigations using our product. And I just wanted to show some of these examples to show that we are actually able to power actual solutions that our users use using the capabilities that I was talking about, just to drive the point home that about the impact of these capabilities. And yeah, I guess that's all the content I had for today. I wanted to open the floor up for any questions or discussion around the capabilities I spoke about. And I also have that Elastic Cloud cluster spun up. So if anyone wants to see any of these tools in action, happy to show that too.
Hi, yeah, thank you for the webinar. I have been getting into cybersecurity and acquiring open source information. And in that literature review, they often reference Elasticsearch. So I've been reading about it, but I've never actually gotten an introduction to it functionally. So this is really nice to see it applied towards cybersecurity.
That's awesome. Yeah, so have you started experimenting with the security product, or are you just using the search functionality in general?
It's mostly just security. So our method is we just look at open source taxi servers. So that would be the generic like Python one that they give us allowance to, and then Alien Vault. And now we're really just playing with taxi
Oh,
query
taxi,
language,
right.
but it's super not fun because you just get this big streaming output of data from everybody who's like dumping data into these repositories. So it'll be really nice to put that
Right.
into a repo and then process that and look for something specific.
Yeah, for sure. I think I've, at least for security use cases, I found the anomaly detection module in Elasticsearch super useful. And yeah, like sometimes if a lot of times we've just ingested data into Elasticsearch and let the module find interesting things in the data. So yeah, I agree. If you have a bunch of streaming data, it's definitely a good use case for something that Elasticsearch can handle and expose anomalies in.
Absolutely. And I know the latter steps after using something like Elastic Stack, they mentioned some tool I'm not familiar with, but ultimately it goes into maybe a dashboard. So this is really good for really quick real-time applications where you get data that's been processed for like in next immediate use.
Yeah, for sure. Actually, let me drop my LinkedIn if someone wants to connect and if they have questions in the future.
I
make
think
that
that's
work.
great. I
Yeah,
understand again, Elastic has so many offerings. And so sometimes as a student, if you're not familiar, if you're not forced into using it, you don't have a clear understanding of all of the benefits. I have a
yeah,
faculty who was part of Open Cloud Institute, and recently he told me that one of his students went out for an interview, and because they were more proficient in Elastic, that was the deciding factor on getting that job out of all of the other applicants. So definitely we do see this as a very positive resource, and we want to continue to bring um, multiple webinars to OCI and to our community. So again, if there's anything that we see along the way, we do try to canvas the group post the webinar. So we'll definitely reach out to you and Stephanie to discuss what other webinars we'd like to see in the future. So thank you so much for your time. Again, I'll offer another quick round to the group if there's any questions, and if not, we can wrap up.
sure. Yeah, and I dropped my LinkedIn in profile link there. If you want to connect and shoot me questions later, feel free to as well. But yeah,
Thank you,
I
Apoorva.
had a great time presenting. Thank you so much for having me.
Wonderful.
All right.
And as we mentioned in the comment, this is going to be recorded, or this is a recorded event. So all of the recordings will be edited and then put on YouTube. So this, along with any other webinars that Elastic's provided us in the past, will also be there for any students who maybe are still new and can want to revisit the intro to Elastic. If you have any specific questions, let us know. And again, thank you for joining us today.
Thank you. Bye.